Okay, welcome to the first of hopefully many No Lift journal paper reviews, where we take a deep dive into a research paper, examine it, and determine the key practical takeaways from it. So, my name is Arthur Lynch, and for this episode of the podcast, I'm delighted to say I'm joined by PhD student, Olympic weightlifter, and Clark Kent lookalike, Ian Darragh.
Uh,
Ian, good morning.
hi,
How are
hi,
you?
hi, Arthur. Thanks for having me on.
How are things with you?
Okay, yeah, not too bad. Surviving the end of the world is the kind of joke I keep saying to people when they ask me this question now. I think that's probably a bit dramatic, but yeah, look, it's a bit boring at the minute, but can still train and working away a little bit and all that sort of stuff. So it could be a lot worse, you know.
Have you been rained out of it during training much?
Yeah, so I'm training in a back garden at the minute, and it's fine now that it's the summer months, but it's been uh we were resilient this winter. Like there's going for like legitimately like 5 RM squats, and then it just starts hailing in the middle of December, and it's dark and it's cold, and you're like, okay, it's a bit metal, but it's like also very unpleasant. But yeah, no, it's fine. It's not too bad. Again, like have a bar, have enough weights for it to be hard, all that sort of stuff. So again, I really can't complain when there's people swinging 2 kilo dumbbells around for hundreds of reps. And that's their only option.
Yeah. Now, before we begin the review, can you give the listeners a bit of an introduction to yourself and your background?
Yeah. I suppose not a massive amount to say. I don't like doing the whole like these are my credentials thing, but I guess just kind of for a bit of context. So I have an undergraduate degree in sports science from Dublin City University. Um, and secondly, I have a master's degree in molecular medicine and molecular biology from Trinity College, Dublin. And now at the minute, I'm back in DCU doing a PhD. I was going to say PC, doing a PhD in kind of more translational physiology. And I guess when you kind of talk about my expertise, if I was to have one, I would like to think that's kind of the area that I'm specialized in. So alongside kind of having a more basic science background from an educational perspective, I've also worked as a practitioner a little bit. So I worked as a fitness coach for a couple of years, a little bit of strength conditioning, Olympic weightlifting kind of coaching as well. And I guess the area that I kind of find myself interested in is looking at kind of studies like this that are maybe more physiological in nature, or a little bit more basic in the kind of information that they are generating or investigating, and then trying to figure out whether, to be honest with you, trying to figure out whether it actually has any meaningful implications for actual practice, be it clinical or performance. Because I see, and a lot of my interest in this has come from kind of irritation, where I'll see, not to be calling people out, but you'll see a lot in the social media age, like muscle protein synthesis this, or a picture of something molecular, and be like, now train in this very specific way because of this very small niche thing. And you're like, well, that probably doesn't actually matter when you consider like these whole factors. So I was kind of like, I want to learn these things and figure out, do they or don't they? Kind of a debunking thing is probably more my area of interest.
Yeah. Yeah, I agree with you on that one. And like, I definitely find myself, I'm more often than not telling people, yeah, that's probably not going to work than anything else. Or, you're probably extrapolating beyond what the data in whatever study they're uh, taking their conclusions from actually represents. So yeah, I definitely I get where you're coming from on that one. Um, so shall we get straight to it?
Yeah, we certainly can do.
Cool.
Yeah.
So for those of you that are listening to the audio only version of this podcast, I'll include a link to the paper in the show notes, and if you want to check it out for yourself. But for those of you that have the luxury of video format, I'm actually going to share the paper here so that you guys can follow along as we're talking. Right, so the title, Hyperventilation-aided recovery for extra repetitions on bench press and leg press. So the title is quite engaging. I think it's quite an interesting one. So where do you want to start with this one, Ian?
Well, I think the first thing to do is probably delimit what we mean by hyperventilation in terms of the kind of like, you know, because it's I actually think in this circumstance, and when you talk about hyperventilation as a ergogenic strategy, it's quite specific, because obviously, so when you like, ventilation is just essentially the breathing cycle. So you breathe in, you breathe out, you know. Hyperventilation then is obviously kind of excessively breathing or respiring. And there's hyperventilation where if you're engaged in like a maximal bout of aerobic exercise. So if anyone has ever, you know, if you've done like a VO2 max test, or even if you've run like a mile for time or something like that, where you start to like pant at the end, that's hyperventilation when you're very, very fatigued. But the type of hyperventilation that they discuss, at least in this study and kind of in some of the other research done by these specific researchers, is slightly different. And that's where it's kind of more of a, you are going to be breathing at an increased rate, so you're going to be panting a little bit more, but there's also like an intentional increase in the depth with which you breathe. So I don't know if it's going to be silly for me to kind of mimic what this hyperventilation is supposed to look like, but it's essentially what you're doing is like, and you can hear it when if it's used, because this is used as a strategy particularly by like free divers and stuff like that as well. And when it's done, it's like a big inhalation in, and you can hear like, it's almost like a death rattle exhalation, because it's so forceful, you know, it's a like that push, and then it's repeating that for a fixed period of time. So that's what's meant by hyperventilation, at least in this context.
Yeah. And so you'll recall a couple of years ago when we were teaching assistants at the University of Limerick, there was a demo lab we used to do with the third years where, you know, we would get a volunteer to hold their breath, and then that would be kind of like your control condition, and you'd record how long they could hold their breath for, and then you'd get them to repeat that following a period of hyperventilation. And if you do that, you should be able to hold your breath for longer. And the reason being is the forced expiration of CO2, this hypocapnia. So you reduce the partial pressure of CO2. We should probably explain that term.
Yeah. So so I mean the partial pressure of, so when we talk about essentially kind of concentrations of gases in the blood, and obviously the two that we are predominantly concerned with are oxygen and carbon dioxide. Oxygen is the gas molecule that we use for respiration to produce energy and stay alive. And then carbon dioxide is obviously the end product of, or an end product of aerobic respiration. So, you know, we kind of consume oxygen from the atmosphere, and then we exhale carbon dioxide as an end product of respiration. And when we talk about the partial pressure, that's kind of our proxy indicator for the amount of each gas in the circulating blood. It's also used in when you're kind of considering the amount of air in the atmosphere and stuff like that as well, for, you know, altitude or, you know, pressure diving and stuff like that as well. But I guess in the context we're talking about it today, to say having a high partial pressure of carbon dioxide would imply that the amount of carbon dioxide relative to the total amount of gas in the blood has increased. And a low partial pressure of oxygen would imply, you know, that the amount of oxygen in the blood has kind of decreased. I don't think we need to kind of give, you know, Boyle's law and Henry's law and all this sort of stuff, but I think it's better to, or it's easier to just to discuss this as these are the proxies for the amount of gas in circulation. And then to maybe put this, just to maybe make it a little bit clearer, for example, when you inhale, you inhale, oxygen enters your bloodstream, you'll have a higher partial pressure of oxygen in your arterialized blood, which is the blood that is going from the heart into the peripheral tissues, and you'll have a lower partial pressure of oxygen in your venous blood, with the reason for that being that this blood has passed through systemic circulation, the oxygen has entered tissue to be used for energy, and therefore it has been lowered. So that's kind of a way to think about it.
Yeah. Right. So we'll go through this, I suppose, section by section. Introduction, I suppose we don't need to say too much about this. They talk about some of the strategies that you might use to provide a buffering mechanism, buffering the acidification. I don't know if that's the right word, but that accompanies, strenuous exercise of this nature. And one of the proposed strategies you might use is sodium bicarbonate supplementation. Now, the research there for resistance exercise is not particularly convincing. And you also have the chances of some gastrointestinal distress, potentially shitting yourself. So this is an alternative strategy that you might use to reduce the drop in pH and the increase in hydrogen ions that accompany this type of exercise.
Yeah, and it's probably, just as you started talking there, I was like, crap, we should probably talk about how all of this relates to fatigue, because the purpose of this study is to investigate say a relatively novel ergogenic strategy for offsetting fatigue in sets to failure and resistance exercise. And I know your listenership is probably more on the applied end of things, so they're like, I don't care about how this works, I want to know if this works. And like I don't know if you've ever actually looked into kind of fatigue during exercise in any kind of detail, but it's an extremely complicated and not very well understood process on a collective, like from a collective or an integrated perspective, which to me makes it quite fascinating. Because like, I guess we could maybe, I could maybe summarize the idea that they're trying to convey in the introduction. I actually don't think, maybe as we get through the results and discussion, that they're entirely on the money with how they think this is supposed to work. And I think the reason for that is that they make the comparison between sodium, like essentially as hyperventilation, and sodium bicarbonate. Potentially, if bicarbonate was to work in this scenario, that it would be that the benefit of bicarbonate ingestion and the benefit of hyperventilation would be mediated through the same mechanism. I don't think it's the same mechanism. I think it's a similar and related mechanism, but it's not exactly aligned, which to me also makes this a little bit interesting. So maybe we could summarize. Would you like me to kind of summarize, like, essentially
Absolutely.
why does an increase in so the idea here is, and it's actually to relate to, there's kind of I guess you could call it an accumulation of tissue just along the side of your neck called the carotid body, and essentially what this does is, as blood passes through your neck and reaches the brain, there's sensory chemoreceptive cells in the carotid body that sense for the partial of pressure of carbon dioxide and oxygen, and then also are sensitive to pH as well. And essentially, when these cells detect changes, they will signal to the brain and go, okay, we're in respiratory distress here. So, as you begin to exercise, if the partial pressure of oxygen begins to drop, they'll sense this and you'll start to breathe more. That's kind of where this comes from. And one of the strongest signals for respiration is the partial pressure of carbon dioxide. So as that increases, you'll begin to kind of, feel the urge to breathe more. You'll begin to respire more deeply and more frequently. So I guess the example is with the free divers. So what free diving is, there's numerous types of free diving, and I'm definitely not an expert on it, but I think the general concept is you don't have like a rebreathing tank or an oxygen tank. You just hold your breath and try to swim as deep as you can, And so the benefit of hyperventilation in this scenario, when you hyperventilate, what you're doing is you're forcefully blowing off carbon dioxide. So you're essentially intentionally reducing the partial pressure or the amount of CO2 in your blood, while keeping your oxygen saturation or your partial pressure of oxygen approximately the same. Sorry. So the benefit of hyperventilation in that scenario is you essentially offset that signal to your brain. And what that means is if you're holding your breath, that like choking feeling you get when you hold your breath where you're like, I need to breathe, that's offset. You can hold your breath for longer, you can go down for deeper. That's essentially the idea. What bicarbonate does then is slightly different. So carbon dioxide in the blood isn't actually, it's mostly not transported as carbon dioxide. So when oxygen is circulating in the blood, it's mostly bound to hemoglobin. It's something like 98% of oxygen is bound to hemoglobin. Carbon dioxide isn't the same. Carbon dioxide is actually transported mostly around 70% as something called bicarbonate, which is HCO3. Carbon dioxide is CO2. This is HCO3. And it's buffered that way. So actually, when you look at the partial pressure of carbon dioxide between arterialized and venous blood, the concentration change, or the, sorry, it's not concentration, but the partial pressure change actually isn't as substantial as it is with oxygen. And that's because carbon dioxide is mostly transported as bicarbonate. So the idea with sodium bicarbonate ingestion is you are essentially exogenously administering more of this. And also when you're talking, sorry, I have to take a step back there for a second. So bicarbonate also transports hydrogen ions, which are one of the kind of principal ions which will decrease your blood pH, so make your blood more acidic. And again, this all ties back to signaling to the brain essentially and eliciting fatigue. So when you ingest sodium bicarbonate, you're essentially creating temporarily at least a greater amount of bicarbonate, which is able to kind of attach these hydrogen ions and transport them away. And hydrogen ions are actually blown off, at least during exercise, through the exhalation of water. So there's a little bit of water in your breath when you breathe out. So the principal difference here, when they talk about sodium bicarbonate and they talk about hyperventilation, the thing you need to think about is when you ingest bicarbonate, you're not actually going to see any change or a substantial change in the partial pressure of carbon dioxide. Instead, you're creating a buffer to kind of sequester hydrogen ions away a little bit more. Whereas in hyperventilation, you're not seeing a change in that kind of buffering capacity per se. Instead, you're blowing off carbon dioxide. So you're two separate scenarios here, and both of them will signal in the same way, in that by alkalizing the blood, you will have a lower kind of drive through the carotid body. But also by lowering the partial pressure of carbon dioxide, you'll see a similar effect. And the question is, which is more powerful? And then obviously the specific context in terms of exercise we're going to talk about. So the idea here is that they've made them analogous, but it's not necessarily the case. But in either scenario, the idea of how either one would work in terms of resistance exercise is that you are altering. They actually think it's to do with more peripheral, and we'll talk about it probably when we get to the discussion, but the argument they make is more to do with kind of the peripheral effect of hydrogen in the muscle. So when you increase the HCO3 amount in the blood, hydrogen ions are more likely to efflux out of the muscle. And in the muscle, there's kind of some argument that hydrogen ion will interfere with contraction. And what that means is if you have less hydrogen in your muscle, so to speak, you're going to be able to do more reps. So that interference will occur later. And that's the idea with the alkalosis.
Yeah. And then just finally, just for the listeners, just to clarify for them. So would I be right in saying that pH and hydrogen ions are inversely related?
Yeah, sorry. And actually pH stands for power of hydrogen, just in case anyone was ever wondering. But yeah, so essentially it is, yeah, so by inversely related, you mean the greater the amount of hydrogen in, say, your muscle, the lower the pH, so the more acidic it is. That's the case. Yeah.
Cool. Right. So we'll skip on to the methods then. So subjects 11 power trained males. So again, we might talk about later on if it matters that you know, would this be different in females or something like that? But a pretty good sample here, in fairness. So 7 throwers, 2 rugby players, 1 judo player, and 1 middle distance sprinter. Their 1RM strength, 129.1 kilos on the bench press. Now it's a Smith machine bench press, so I don't know if that's pertinent. And then on the leg press, 208.1 kilos. So pretty decent level, in fairness. Have you any comments about the sample size or anything like that?
No, the only thing is, and it'll probably be more important when we talk about the results. The only thing I didn't like about this is they don't give you kind of an indication of the spread. So like the bench press, you see it ranges from 102 kilos to 162 kilos. So while you have an average there that's pretty decent, it would be nice to see. And because they only have something like 11 participants, which isn't bad, but it would have been nice to see maybe a table where you like participant 1, this was their bench press, participant 2, this, just to get a more comprehensive idea of it participant by participant. But no, apart, like they're definitely resistance trained. They're clearly competent in training, you know, which is important for this kind of study, I think.
So let's talk about what they did then. So this study investigated the benefits of hyperventilation-aided recovery for lifting repetitions and velocity during 6 sets of bench press and 6 sets of leg press, where each training set was performed at 80% of 1RM until lifting failure with a 5-minute recovery between sets. I actually quite like that, a 5-minute recovery. That's a
short recovery for you.
Yeah, that's probably still a short recovery for me, but it's closer to, you know, something that I might actually do. And so then for the hyperventilation aided recovery, subjects initially recovered with spontaneous breathing for 4.5 minutes, and then for the final 30 seconds of the 5-minute rest period, they performed the voluntary hyperventilation for the remaining 30 seconds. I get the impression that they denote it as voluntary just to prevent anyone from like passing out or something like that.
And like, I mean, I think the other thing here is, I guess if anyone listening ends up reading this study, you'll see it as we progress the other figures. The intervention here is a bit, I don't think it's wrong, but it's a bit odd. And it actually took me a read or two to understand. Like, I was getting confused at the start. They haven't done an intervention here where it's just like 6 sets, 1 group or 1 session where you just don't hyperventilate, and another session where you do hyperventilate in the last 30 seconds of each rest period. Instead, they've done it kind of funny where the participants came in twice. They did the 6 sets to failure both times on both exercises, but the order in which they did the hyperventilation changed. So for example, in the first set, you don't hyperventilate. Then in the second set, you do. And then in the fourth set, you do, or the other way around, where you start in the second set, go to the, you know, it's a bit, I think figure 2 shows it kind of nicely as an example, but it is a little bit, it's probably just as a caveat that this wasn't a straight up comparison, which I thought was a bit funny. And yeah, and that's something we can talk about maybe when we get into the more practical applications. Hyperventilation can make you feel a little bit weird. So like, you know, you can get dizzy, or you can get paresthesia, which is like if anyone's ever taken like a pre-workout with a crap load of beta alanine in it, and my skin gets really itchy when I take something like that. That's kind of similar to paresthesia. Your fingers start to like pins and needles. So I think that's where the voluntary comes in, although they report that participants were asymptomatic for that throughout. Whether that's worth anything or not, I don't know, but
yeah, kind of have to take their word for it. So as you noted, it was kind of it was actually a crossover design. So basically, it's either the hyperventilation condition precedes either set 1, 3, and 5 or 2, 4, and 6, and then they cross over and do it the other way around in the next session, separated by 48 to 72 hours. Anything else noteworthy here in the method section that you wanted to highlight?
It's probably worth saying now, and I think we'll come back to it. I know I keep saying that, but it's just that these sessions were performed, so the reps to failure, but they were performed in machines, and I think it's a Smith machine bench press and then a leg press, obviously, and I think that makes the result. It's probably worth highlighting initially because it makes the results of this study a little bit finicky when it comes to thinking about like free weight training, so barbell bench press or squat. We were talking about this just before we started recording, where like if this intervention is going to make you dizzy and you're in any way strong, you're like, all right, I'm going to do a top set at 200 for 5 on the squat. I'll just make myself a little bit dizzy first. The extra rep you could theoretically get, or the extra couple of reps that you could theoretically get from hyperventilating, may be negated by the fact that you feel like you're about to fall over. So while this is promising, and it might be, I don't like to think anything is ever useless, but it's probably a caveat to think about, people who are like, oh, I might use this in my squat session later on, or my bench press session, or God forbid your deadlift session where you'll definitely fall over. That's the only thing, the methodological thing I'd finally highlight.
Yeah, well, at least with the deadlift, a bar can't fall on you. You might fall over the bar or fall into something, but at least a bar can't drop in your head or something like that. Right. I guess we'll move on to the results then, really.
Yeah. I think that the thing to point out there is I don't know about you, I wasn't that interested in the velocity data, to be perfectly honest with you. I guess because the whole thing is repetitions to failure, and like the only thing that I guess spoiler alert is there is a tendency to do more reps when you hyperventilate, and they're like, and also the reps were faster. It's like, because they did more reps, but the final reps were probably equally as slow, so that's it's I think the real data of interest here is the repetitions, the number of repetitions.
I might have given a bit more weight to that if the workload was fixed, and you might say, all right, well, for the same set of, say, 8 reps, they were performed at a higher velocity under the hyperventilation condition, and that might be useful because you might say, all right, well, the RPE might have been lower on that set, with the intervention. But with this design, because it's reps to failure, I'm going to be more interested to see just did they do more reps.
Yeah. And then even then, because it's reps to failure as well, when I think about this in the context of because the other thing about interventions like this is it is, I know it's a crossover design, but it's technically one session. And so you go, okay, this works for one session, and that's great, but it doesn't mean anything unless it works for a bunch of sessions in a mesocycle or over a couple of weeks, because that's when you're going to actually see the benefit. So when I think about this in terms of reps to failure, then all I can think about is hypertrophy, so you're like, okay, is this going to help me do enough reps over a month to make me, build a little bit more muscle. And so, do I care about my lifting velocity in that context? Not really, probably not. It's all volume that I'm interested in, Yeah,
and I suppose it might be worth noting that this is the kind of thing that's very hard to blind subjects from. So you have that initial sort of, oh, I'm doing this thing. So there's all sorts of potential belief and expectancy biases that could, I won't say confound, but they're worth factoring in, and then maybe they are diluted then over time, potentially. But I mean, if their physiological rationale for this is sound, then that shouldn't be the case.
Yeah, and I actually do think I'm a little bit nervous that I butchered my explanation of how this is meant to contribute to fatigue at the start, and I think we'll come back to it a little bit. But I do actually think there is a physiological rationale for how this could work, because it seemingly does work. I was actually a little bit shocked by the amount of repetitions that were reported as different between the hyperventilation trials and the normal breathing trials. But it's funny that you say, yeah, about the blinding, and perhaps that's maybe one of the reasons why they did this in this way, where there's kind of two sequences of the hyperventilation. And you'll see as we move into the results here, what they do again when they compare them is a bit funny, in that they don't compare it trial by trial so much. Instead, they bunch all the hyperventilation trials together and then compare them to all the non-hyperventilation trials across 2 separate days. And there's probably merit to that and criticism that can be landed on it too. But yeah, I think maybe that's one of the reasons, because I actually hadn't thought of that. But yeah.
Right. So in terms of the results then, so number of repetitions, so under the hyperventilation-aided recovery conditions, the repetitions during the bench press were maintained, and during the leg press, they were maintained or increased by between 21.3% and 55.7%, which is quite profound. The thing that's important to note, though, is so that's relative to the previous set, not relative to the first set, which is when I was reading the first half of that sentence initially, I was thinking, oh my God, this is amazing. And then you skip down to the figures and you see actually what they're talking about, and you're like, all right, still good, but not as impressive as it's not as impressive as I thought it was.
Well, I think the key point is they're still getting progressively worse, whether they're hyperventilating or not, as the sets go on, which obviously makes complete sense, for anyone who's ever, like, this is one thing I actually thought about, is this is a hard training session. Like, someone, if you were to like, hey, do you want to be in my study where you do 6 sets to failure on like the leg press? I'd be like, I'm busy that day, like that.
Yeah,
I would, but my knee hurts, not that my knees don't always hurt.
The classic thing in the lab sessions, because that's entirely coercion to get someone to volunteer. Like, that's not a, I'm just gonna be straight about it. Like, you're trying to, I could land myself in trouble here now, but you're trying to get a student to perform the exercise session so that you have something to talk about, more or less. So there is a little bit of go on, you'll do it sort of thing. But the classic kind of cop out there is like, oh no, I've an injury. What is it? A hamstring. But
no, I won't name names, but definitely, as like, I participated in a few studies as an undergrad. In my time, I paid my dues, but there was definitely things where people would be like, oh, it's a cycling protocol, but it's tough, but it's not too bad, and it would be absolutely brutal. Like
wing gates or something.
Like, yeah, it's like, it's 10 30-second intervals, but they're not too tough, and it's like 10 maximum effort wind gates with 15 seconds recovery or something like that, and you're like, I can't walk for 3 days after this, but you're like, it's not too bad, don't worry, and you're just like, okay. I think I actually, and maybe I'm just a stupid person, but I found these figures initially quite unintuitive. As in, I was like, I don't really know what's going on here for a second. I had to kind of look at them, look away from them, and look back to them again. But it's maybe worth pointing out that, like, if you just to see kind of, so like, I'm looking at protocol A in the first panel here, because I don't think you can see my cursors, but just to kind of really hammer home the effect of what's happened here. So if you look at the bench press, which is the black dot at the bottom, the first set, they hyperventilate. The second set, there's a decline, I guess probably just because your first set's always your best set. But then in the second hyperventilation set, there's like, it stays level. That's, or still declines in the next set. And then, yeah, that's so the effect of hyperventilation could probably, maybe be seen between 2 and 3, as an example, on the bench press, set 2 and set 3, or in that same kind of, or the equivalent set for the leg press. That was where one of the increases was observed. Just might be worth kind of pointing out, because it was just for me, because I was like, I don't really understand what's going on here for a second.
Right. Yeah. Well, I mean, if your hypothesis is that this will work, I think it makes more sense. But you do have to, like, they put the HV in brackets underneath it, and it's probably not the best way of showing it. But after a while, you're like, oh, now I get it, because
yeah,
that's better relative to that, and that kind of thing. So, that this is, they did the hyperventilation protocol before set 1 here, before set 3, before set 5, and then the opposite here on protocol B. So it's 2, 4, and 6. But yeah, as you say, it's not overly intuitive.
What one? Oh, sorry, go on.
No, go on ahead.
Well, one thing I was curious to know, and they don't even talk about it now. This is, to be fair, this is a lot of studies are guilty of this, in that you don't really, there's no mention on whether every participant actually benefited from this or not. So and that's, again, that probably ties back to my comment about why it would have been nice to see like the actual participant by participant spread. And similarly, it would have maybe been nice to see, I don't know how you would make it, but some kind of figure where you could see how each participant responded. Because something I wonder about is, I guess, like I said, the heaviest bench press was like 160 kilos. Did that guy, did he benefit from this similarly or just as much from the guy with an 100-kilo bench? Because he obviously, like, I can't remember, was it 75% of 1RM they were working at?
80.
80%. So, like, I mean, what are you talking about there? So 160-kilo bench for him, you're talking about like 30 odd kilos off. Like, he's doing 130 kilos, whereas the other guy's doing 80 kilos. Is the hyperventilation going to work for him just as similar? Because it's an important question, again, because it, and I wouldn't say this in a mean, as a means of like disparaging this as a method, but it's just as acknowledging that this method may be useful at a certain point in time in a lifter's progression, but it may become less relevant or more relevant if it was more effective the other way around. Although I would suspect as you get stronger, like we've had this discussion before, and it's a hard one to have, weights feel different as they get heavier, irrespective of the fact that you're also getting stronger. So I would probably suspect that people who are much stronger in the absolute sense would get less benefit out of this, but there's no information here to indicate whether that would be the case or not, which is kind of disappointing.
Yeah. The figure underneath gives you an idea, but it's only giving you the total repetitions.
Yeah.
It's not giving you, it's not providing these type of graphs for the individuals, So as you see, like, and the way the standard deviations are provided, it's a little bit weird because, like, I don't know, I suck at statistics anyway, but I mean, am I right in assuming that the range is from here down to here? We're some.
Oh, yeah. I know people do this now a little bit, but no, that actually wouldn't, the direction would be equal in both ways. So it's
Right.
not, but yeah, I know what you're saying at the same time. But yeah, you're right in that they do have the kind of like the individual participant responses there, and like even you can see there's one guy on the leg press who did better in the control condition. But it would be nice to see, like, still to see that relative to absolute strength, just as a curiosity, because there's also someone down here who's done better. That's hard to see because they're lines, but like, I admit this data is sometimes hard to present, that there's one guy who's done like marginally better in the control condition or roughly the same, so it's obviously, and now I know these are standout participants, so it's clear that it wasn't very mixed, it was pretty consistent. But again, without knowing more on a participant by participant level, you can't at least speculate to factors which might have contributed to why those people, if you're going with the hypothesis that this would work, technically didn't respond, in quotation marks.
Yeah. Anything else on the results that you want to talk about, or will we skip to the discussion?
It might just be worth saying that this is the velocity data. Oh, and then maybe the pH. Yes. That's probably important as well.
Okay.
But like this is the velocity data. There you go. Yeah. And again, it's kind of funny that they did something like this in that. So sorry, just again for people who are watching, like each of these individual points represents, I would presume, a repetition, just judging by the amount of them. So each of these individual points represents a rep. So they could have done something kind of more individual, and you could just get an idea. And what this enables you to do is, obviously the box here is it might be the median. Sometimes when people do a box, or when you do a box plot, it should be the median, but sometimes people swap it for the mean anyway. So these boxes give you an idea of how the groups or how the individuals responded on average, and then the individual points just shows how those points have dispersed to create that median. It would have been nice to see that just for the other plot as well, again, just to give you an idea. And what these are representing is the angular velocities. They use like an electronic goniometer or something like that, I thought. I only skimmed that part of the methods because it didn't grip me, but to measure how fast they were going both on the eccentric phase and on the concentric phase of the lifts, the bench and the leg press. But yeah, there's the data, I think all that matters here is the data kind of aligns with what they found with regards to the repetitions. And that's, to me, not particularly surprising.
Yeah. So then in terms of pH data and the partial pressure of CO2.
Yeah, now there's probably a caveat that needs to be placed on this, because these are recordings of blood pH, partial pressure, and I think lactate. Is lactate in there as well? Sorry, I can only see. Oh no, that's maybe
No.
They reported in the results. They don't put it in a figure, but that's yeah. So, but how they did this was actually at the end of the intervention. So at the end, after the 6th set, in one of the protocols, I'm actually trying to remember which. I can't remember if they hyperventilated in both of them or only in one of them. But after the 6th set, so they've completely finished the intervention. They rest for 4.5 minutes, and they do a ventilation. They do a hyperventilation. And that's when they took these measurements. So like you presume that this is consistent with a control condition, as in if they had not done any lifting, this is how these changes would occur, but you don't know if it was slightly different within the workout itself, which is maybe just a caveat to place. But the thing you need to, I think all they're doing here is like, just so the hyperventilation worked. So so if you see the blood PCO2, which is the partial pressure of CO2, when they hyperventilated, so this is them, I think that's their PCO2 measured at rest. So that's before the intervention started. Then at the start of hyperventilation, that's what their PCO2 was. So once they started hyperventilating, and then at the end of the hyperventilation, and all you can see is from resting PCO2, the initiation of hyperventilation causes a drop, and they drop it down to about 25 millimeters of mercury is the measure, and then that's associated with it should be associated, it's associated with an increase in blood pH eventually here. So resting blood pH is normally about 7.4. That's during the recovery, it's a little bit more acidic, but again, they've just finished the intervention there, so that's probably why. And they do report in the results section, there's elevations of lactate. I think it's about 7 for the bench press and about 9 or 11 or something like that millimoles per liter, which is just, and like, again, that's getting probably I'm probably getting a bit too technical there, but all that signals is the lactate itself wouldn't actually lower blood pH, but increased production of lactate is associated with accumulation of hydrogen ions and acidification. So the lactate itself is just a signal of hydrogen ion accumulation. That's all that is. So that's why the blood is slightly more acidic during the recovery phase.
It's in the back seat, it's not driving the car.
Exactly. Well, it's just they're produced, or they both kind of see an increased abundance through the same process, which is glycolysis. So to have a high amount of lactate is a high amount of glycolysis, which would have a high amount of hydrogen ion accumulation. So it's just a signal, and it's an easy to measure one. Actually, something to point out here that I did want to say, because this is really important on the practical side. So how you measure, that's blood PCO2, but actually how they got the participants to you can also measure expired CO2 and use that to calculate what's called end-tidal PCO2, and essentially that's the partial pressure of oxygen in the expired air, and that's pretty closely related to blood PCO2. Like, it's usually kind of 1 to 2 millimeters of mercury out, so not an amount that's practically meaningful. And that's actually something they used in the intervention. So these participants were hooked up to a respiratory device. Again, for listeners who aren't familiar with physiology labs, it's, if you've ever seen like a Rocky movie where someone's running with like a mask on their face and they're breathing into a big, like a bag or something like that, or there's a computer hooked up, that's basically a respiratory apparatus that is measuring gas exchange at the lung. And they used like a computer when these guys were hyperventilating to ensure that they had a drop in end-tidal PCO2. So essentially, while these guys were hyperventilating, they also had a visual way of ensuring that they were creating, that they were blowing off enough carbon dioxide to get some kind of alkalizing effect or hypocapnic effect. So practically speaking, you need to be careful, because if you're like, right, I'm going to go and do this, you could be hyperventilating in a way that's not getting your PCO2 down to a level that's going to mediate an effect.
Yeah.
And you're like, why is this not working? You know, and there's no phone app that you can breathe into to tell you that your partial, your expired PCO2 has dropped to 25 millimeters of mercury. And they do kind of harp on this PCO2 level as being kind of approximately where you're going to see an ergogenic benefit. So that's important to remember as well in practice. If you're like, I'm going to do this all my athletes in the gym, you don't know if it's working for them or not, if they need to. And these guys actually individualize their technique. So it does say in the methods they were allowed to alter their respiration rate, or the expired volume of air, basically how quickly they were breathing or how heavily they were breathing, to individualize the most comfortable and efficient way to lower their partial pressure of CO2 and expired air. So that's important from a practical perspective when you're thinking about this in the gym, because it's hard to know how it's going to work unless you go to a lab and practice it.
Yeah, so that might segue quite nicely into the final set of figures, which I don't think we covered just yet. So it's on page 5, which I think are quite. It really demonstrates the amount of work that got through in that 30-second period. So if you look at these bars here, they're like in the control condition. So that's, for example, the minute ventilation. So that's your tidal volume times your respiratory rate. So if you think of the amount of air that flows in when you inspire or when you inhale, times the number of breaths per minute. And that's after 4.5 minutes compared to the 30 seconds of hyperventilation. So it's quite a profound effect when you view it in that sense.
Yeah, and I mean, just like, so this VE is basically just how much air they breathe in and breathe out, average per minute, or like kind of estimated per minute, like you say. So yeah, and you can see it's like it's 4 times higher or something like that, you know. And like, again, this is, I would actually, like, without sounding like some kind of a, you know, like a nerdy secondary school teacher who's like, you can try this when you get home, you know, it is like, I think the breath holding experiment is an interesting one to do because it works. And all you have to do is get a phone, sit there quietly, hold your breath, see how long you last. It's probably going to be like 30 to 40 seconds. Then do the hyperventilation protocol for 30 seconds and do it again. And you're going to get 10 or 15 seconds, as most people do. Like, if a room full of 40 hungover second year sports science undergraduates can make this work and see an effect, definitely anybody can, you know. But it is quite uncomfortable as well. And I think this, to me, speaks to like this is like, these are values you'd see like during a heavy bed of aerobic exercise, you know. Like, that's, so you're like, this is like, I know it's only 30 seconds, but these are similar respiratory values to like hard cardio, and it's going to feel like that, you know. So that's something to comment on. But yeah, it is interesting to see how much higher it is. I actually think they have the NCO2 there as well.
Yeah.
So that's just what I was talking about, the PET CO2. And you can see, and it actually shows quite well. So in the control condition, they've got about 40, which is about right. 35 to 40 is a normal expired partial pressure carbon dioxide, and then they consistently blow it off to about 20. And that added recovery just at the end there, that's where they're taking those blood PCO2 and lactate measurements and pH estimate, I think, that was in the last figure we were talking about.
So this level they've achieved here, that's what they've theorized in the introduction is where the ergogenic benefits lie, is kind of between 15 and 25 millimeters of mercury.
Yeah, and I mean, practically speaking as well, like you can only blow so hard, so to speak, you know. So like I would imagine that even if it was like, let's say, beneficial to lower your, you know, partial pressure of CO2 below this point, you're probably not going to be able to do it without knocking yourself out. So
Yeah.
you know that and there are like, it's funny, it's probably maybe arguably not as relevant to resistance exercises, but or to resistance exercise, but maybe one of the things we could talk about in the discussion is like, it's not a case of like hydrogen ion bad, you know, kind of O2 good scenario, where it's like
Yeah.
there are physiological changes that occur from hydrogen ion accumulation that are beneficial to fatigue resistance, you know. So there could be an argument that like blowing off harder and trying to increase that process more might not necessarily, it might not just be a stepwise effect where it's beneficial all the way to the moon, you know.
This might be an unfair question to ask because it could throw you off, but like, do you think it's a case of perhaps there is a benefit acutely, but you know, just based on what you've mentioned there, do you think that potentially it could have a negative effect on the adaptive process? Is that kind of what you're getting at there?
No, I don't think so, because this is like, and this is one of the things, now I'm going off on another tangent here, but when you see a lot, like a lot of the qualm I would take with discussion around, this isn't technically, it is molecular data, but kind of, you know, molecular mechanisms and stuff like that, is people look at like temporary changes in a cell and go, your gains are ruined, you know, or your gains are amplified. I think biologically we're just a little more sturdy than that. And the fact that you're doing, let's say you do this and presumably it works, you've done more repetitions. And I think the benefit of more repetitions will be more relevant to an adaptive response than any, even if you could find a mechanism that would potentially say this might hinder your adaptation. I guarantee you the fact that you did 10 more reps is going to, if they're in competition with each other, 10 reps is going to win, you know?
Yeah.
So you go, I'm adding a small hindrance to gain some additional momentum, and you know, you're still running faster even if someone's pulling on you a little bit, you know. That would be the analogy I would use. But yeah, and also it's such, like, we're talking about acute changes here as well. So like, I mean, that like that the acid base balance, like these guys would kind of be at a level within, you know, everything would be back to normal within 2 hours of this training session, say, you know. So
right.
You know, in the long-term context of inducing training adaptation, I don't think it will matter too much.
Okay, on to the discussion. So is there anything in here that you wanted to highlight, or, you know?
No, like I mean, I'm kind of, I'm between a rock and a hard place with this study, because I think they've convinced me that it works, but I'm not convinced that it will work. And I know that sounds funny, but as in like, and I'm just thinking about this from my own experience as someone who trains, I don't ever want to do this. Even if you told me it would give me a benefit, I'm just like, I couldn't see myself committing to it across regular training sessions or even for a training cycle,
right.
you know?
Yeah.
And I think that comes down to so to me, like, I read this and I go, this is interesting physiology, but I just think practically I'm kind of a little bit in, I couldn't see myself prescribing it to someone or anything like that, or, you know, even working with people as a coach. I couldn't be like, right, for this set of clean and jerk, I want you to hyperventilate. You know, I think the classic things are more important, like concentrate, and, you know, that's like concentration and stuff like that are going to be more important than you know, small things like this.
Yeah, definitely. One thing that was included in the discussion that piqued my interest was, because, you know, I'm along the same lines as yourself. Like, I don't see this as being particularly practically relevant, because some of the things we've already talked about, you know, even if you're doing this how can we be sure that you're actually doing this, in the sense that you're actually driving down the partial pressure of CO2 to a point that could be potentially ergogenic in this context. The other thing as well is doing this for 30 seconds. Yeah, I just, I don't know, I'd be slow to recommend it. Now, something I do kind of habitually without realizing is I might hyperventilate slightly before a heavy set of, say, front squats or back squats or something. That's something I just intuitively came to do, and I always found it reduced the RPE for a given, set of 3 or set of 5, whatever the
What
case may
kind
be.
of what kind of protocol are we talking about there? Because I would like, yeah, if I was going for heavy squat, you might go like that before, but or are you talking about something a little bit more protracted?
A little bit more forceful, yeah, but not for particularly long. So I mean, I'm talking like maybe 5 seconds kind of job. So when I read the title of this, I was like, all right, is this in line with what I do? And so when you read through the methods, you're thinking, okay, this is great. I wonder if I could get away with a shorter period of hyperventilation. But that just doesn't seem to be the case. And they cite a previous study of theirs where they did a sprint interval protocol and compared a 15-second with a 45-second hyperventilation protocol. They didn't find any benefit to the 15-second protocol. So, I mean,
well, I actually looked at that study. So yeah, I guess the comparison between sprint interval training is like very short, like 10 to 30 seconds, and even 30 seconds is pretty long for sprint interval training. So like it's similar-ish to what a set of like lifting would kind of be like, this, depending on the exercise, obviously. And actually, I looked at that study very, very quickly this morning, but they actually didn't find an ergogenic benefit of hyperventilation at all in that study compared to the control condition. So, but yeah, it was 15 seconds of hyperventilation versus 45 seconds. And I think like one of the things that I do, like 30 seconds is a long time in that context. And again, I think the thing to always think about with like when you're talking about like ergogenic practices like this, it's like everything has pros and cons. So one of the things I thought about is like just the psychology of it, where you go like lifting is uncomfortable, like a set to failure is uncomfortable and it's scary, and you're asking yourself to make yourself uncomfortable before getting even more uncomfortable. And like like for me, I feel like my resilience is a on a given day is like it's a resource, and it's finite and it gets drained. So if I've only got kind of so much willpower in my day, and I want to dedicate as much of that to my set of squats as possible, my concern using something like this, because it is uncomfortable, is I'm taking some of that resource and allocating it into something else. And I wonder, like, you go, oh yeah, but the hyperventilation will help you. And it's like, yeah, but maybe just saving more of my grit for the set of squats would help me more, like that, and those comparisons are hard to make. And they're more, I guess that's where kind of, if you talk about like, translating the science into the art of coaching, that's where you kind of answer those questions. I don't think you can write them in a review paper or whatever, but that's again one of those concerns that I would have.
Right.
It's uncomfortable,
Mm-hmm. Definitely. And yeah, and like the doing it for 30 seconds again, like you alluded to earlier on, if there was any hint of dizziness or that mightn't have been exposed with something like a leg press or a Smith machine bench press, but if you're unracking a heavy squat, or any kind of free weight exercise, I just feel that there could be some sort of disruption to balance, or if you get lightheaded or that kind of thing, and all of a sudden guy passes out or something like that, that's not good.
No, and like again, when you put that, and again in the context of something like powerlifting as well, where like if you've got a super heavyweight, someone like who's, say 140 to 100 and probably upwards to 180 kilos in body weight, they're squatting like, your Ray Williams, you're squatting north of 400 kilos. Like, hyperventilation for a guy that big could have a serious negative effect for him. And also, I have no idea what squatting 400 kilos feels like. But I can imagine like that it's like my 1RM might be half of that and it feels heavy, but I can imagine it's completely, even if I was strong enough to squat 400 kilos, it doesn't feel like 200 kilos feels for me now, like it just changes with the absolute load. So, but again, like that doesn't speak to its uselessness in the sense that you go, well, if I can get like some novice intermediate lifter who can do this for, once in one session a week for 4 weeks, and it gets them a 10 or MPB that they weren't going to get, that's arguably useful. But it all boils down to, I would say it probably boils down to how uncomfortable the hyperventilation is going to make the individual feel. If you've got someone who's like, this actually doesn't bother me that much, and they're at a level of competency with their lifting where it's not going to knock them out, it might be useful, but like, I don't know. I'm just kind of like, you could just do another set. You could just do, like there's the other thing as well of like, this is repetitions to failure as well. I don't really know anyone that comes in and goes 5 sets to failure is my, it's usually more conservative than that when it's in the context of a training program as well. And you go, when you're pushing yourself to your absolute limit for repetition, this might be beneficial, but how often are you actually doing that across multiple sets?
How I would maybe view that is, okay, well, if this protocol meant that they could get more repetitions before achieving failure, then presumably that means that for a pre-prescribed workload, that you can get through that at a lower RPE.
It's actually worth looking at. I didn't look at the first sets between the 2 interventions, or I can't recall. Did they get more repetitions in the first set?
I think so, yeah.
Oh, did they? Okay. Oh yeah. Okay. Yeah. So you're talking about like 3 point something reps. Yeah.
Well,
or no, sorry. That's
Now that I mention it, I mean, like, they don't seem to have done any comparisons there, but that doesn't look different from that.
No, I was actually sorry. I was comparing the bench press to the leg press on the A protocol there. I was but that looks about, well, I mean, like, if there's a difference on average, it's less than 1 rep. So again, that's one of those things. So if you are doing a top set to failure, this might not have an effect. It's more fatigue resistance than absolute, as in fatigue resistance across the session instead of absolute capacity to complete a single set to failure. Now maybe for a bodybuilder or someone like that, this is going to be useful, but
especially if they're using a leg press, because then the risk of a bar falling on you is, maybe not. Like, you can still hurt yourself in a leg press, trust me. If you don't re-rack the weight properly, something like that.
That's one of the I don't like leg pressing, because I have that fear of, like, particularly, sometimes where you lock the handle in, you're like, is this locked? I don't mind an old horizontal leg press. That's a little safer for my weak brain.
Just don't lift. Just eliminate all chances of weights falling on you.
I'd probably be much happier if I didn't.
Right. Okay, I think we can wrap this up now. This has been a very good low battery. Whoops. I guess it's a great time to finish up. I think this has been a really good first attempt at this. Like, we'll obviously get better with each version of this, but for a first crack at it, I think we did really well. Ian, thank you so much for giving up your time to chat to me. It's been really fun. And thank you so much for coming so prepared to this discussion.
Thank you very much for the opportunity. I really enjoyed it.
Sweet. All right. Take care, and we'll talk soon.
Bye bye.